Hello, this is Dr. Mears. Today I am going to be doing a couple math studies, paper 1 or 2 questions on probability. And I wrote some rules down. We have the union rule, conditional probability rule, and independent events rule. I also should write down our mutually exclusive rule. CLUSIV. And remember, mutually exclusive is when the probability of A and B happening is going to be 0. So that's mutually exclusive when they don't have anything in common. So there'll be no overlap for our circles if we did a Venn diagram. Okay, let's look at these questions. You also should have this sheet, so I can try to zoom in a little bit more so we can read them. That's a little bit better. I'm just going to read them to you. For events A and B, the probabilities are probability of A, 4 over 13, 4 out of 13, and probability of B, 5 out of 13, or 5 over 13. Part A asks if the events A and B are mutually exclusive, write down the value of the probability of A and B. Now, here's the word that you should underline, and that's mutually exclusive, and they're saying if they are. So if they are, they want you to find the probability of A and B happening. And so if we look up, we just went over this rule. If they're mutually exclusive, they have no outcomes in common, so the probability of A and B happening is going to be 0. So we're going to go back over here. So this answer would just be 0, and that's it. Let's go to our next one. If events A and B are independent, find the value of the probability of A and B. So now we're underlining the word independent. So if they're independent, so we're switching it a little bit. Now they're asking something different. So we're going to be going to the independent rule because they told us if they're independent. So here's the independent rule. And what it says is the probability of A and B equals the probability A times the probability of B if given that they're independent. So we're going to find that. So the probability of A and B equals the probability of A, which they gave us is 4 out of 13, 4 over 13, times the probability of B, which they also gave us 5 over 13. And multiplication, multiplying 4 times 5, which is 20, 13 times 13, which is 169. So the probability of A and B is going to be 20 out of 169. Part C reads, if the probability of A or B equals 7/13, find the probability of A and B. Since they gave us this or, the union, what we're going to do is we're going to have to use our union rule. And this is where the manipulation of our rule comes in handy because what they want us to do is actually find that A and B, the probability of A and B. So that's going to require a little bit of work. What we're going to want to do is, I'm going to actually, I might just flip, no, I'll put it down over here. So what we're going to be doing is finding the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Let's put in the information that we have. They have A union B over here, that's 7 out of 13, equals, we know the probability of A, 4 out of 13. We add that to the probability of B, which we know, 5 out of 13, minus, and I'm going to make this X right here. I'm going to make that X because this is what's missing. That's what we have to find over here. This is what they want us to find. So I'm just going to label that variable X. That's our unknown. So now we're just going to do our algebra. We're going to be adding 4/13 plus 5/13. That gives us 9/13. Common denominators when we're adding or subtracting. Minus 9/13 minus 9/13. Cross that out. Bring down your minus x here equals negative 2/13. Now, don't panic because this is a negative x, which really means negative 1. And in order to get rid of that negative 1, we divide. So x is just going to change this to positive 2 over 13. And that's the answer, 2 out of 13. So finding the probability of A and B is going to be 2 out of 13. Now that you learned how to manipulate that, we go on to question number 10, which gives us probability of A as 0.5, the probability of B as 0.6, and the probability of A or B as 0.8. I bet you we're going to use that union rule again. Let's see what A asks. A asks, find the probability of A and B. There we go. Since they gave us or, they're going to want us to use the or rule, the union rule. So we're going to write down the same thing that we just did for the previous problem, except we have different information to put in. Here we go. They gave us A or B, that's 0.8. They gave us a probability of A, which is 0.5. The probability of B, which is 0.6. We're looking for our unknown of A and B. Add these two together. 0.8 equals 0.11 minus x. Subtract 0.11 from both sides. We get negative 0.3 equals negative x. Divide x equals 0.3. So this is our answer. Probability of A and B, 0.3. Next, find the probability of A given B. This is a rule that we haven't used yet. This is our given rule right here. So we have A and B, and we have B, so we can just simply substitute this in. So all we're going to do for this one is probability of A given B equals 0.3, which was A and B, divided by B, which is 0.6, and that's going to be 0.5. So this answer right here is 0.5. So this was A and B probability, and this was the probability of B. All I did was I used the formula that was given up here. And lastly, decide whether A and B are independent events, give a reason. So what we're going to want to do is go back up here, use this rule. We do have the probability of A and B, that's what we found in part A, that was 0.3. We do have the probability of A, which is 0.5. We do have the probability of B, which is 0.6. We want to see if these two multiplied together give us 0.3. That's how we prove it's if it's independent. So let's see. Does 0.3 equal 0.5 times 0.6? 0.3. Yes, it does. Yes, so they're independent. Because the probability of A and B equals the probability of A times the probability of B. And you're done. Hope this helped. Sorry I had to keep moving the paper down and over. Kind of ran out of room. But ask me questions in class. Thank you. Hope it helps.